before, as we move on to the next section, talking about triage, right? Do you mind motivating and giving a bit of background about where triage came from and how you envisioned it?
Sure. Yeah. So we're gonna have Tristan, who's been working on helping build Triage for the last couple of years, give details. But basically, Triage is our you want to call it machine learning data science pipeline tool, right? Well, what the reason we built Triage, and we're gonna go more into that, was we realized that at DSSG and at working with different projects with different organizations, we were repeatedly kind of tackling similar types of problems. We would work with a school district to help them figure out which students might not graduate on time. And so that's an early warning system. We would then work with the health department to build an early warning system to help them figure out who might not stay with them, come back to them, who has an HIV patient and needs to get their prescriptions. Then we work with police departments to help them build an early warning system to figure out which police officers are going to do horrifying, stupid things. We worked with unemployment agencies to help them figure out who is going to be long-term unemployed. These were all examples of early warning systems, and they had the same components over and over again. And so we were just doing the same type of system in different ways. Same for a lot of inspection systems that we've talked about. You know, for example, the one that Jane and the other Brew brother was working on with EPA on identifying which facilities to inspect, or which homes to inspect for safety, or which workplaces to inspect. So we were finding we were kind of doing these repeated problems, and so we built Triage to go from the tools we had access to off the shelf for things like sklearn and TensorFlow and all the other modeling tools, right? So there are tons of tools to build models. Takes 2 lines of code, given a matrix, you build a model and you're done, right? That's the easy part. The hard part was really, how do we go from how do we define the problem? What should be our role? Is the system being used to do weekly resource allocation decisions, which places to inspect? Is it monthly? How far out is the inspection being scheduled? What is the outcome we're predicting? Is it who's going to graduate on time, or who's not going to graduate, or who needed a certain support program? All of those questions, you know, the reason we built sort of Triage was to compensate for our laziness, basically. That's why we build any tool, right? Because we're lazy, we cut corners, and we wanted to kind of not cut corners. We, for example, when we do a machine learning project, generating features takes a long time. And so sometimes we might not generate all the features we want to generate. Like, we'll come back to it, and sometimes we don't come back to it. Or we build a bunch, we take one outcome, one label, and say, well, let's try this for now, and then we'll come back and try others. And we sometimes don't come back and try others. Or we build a bunch of models, and then we sort of, you know, say, okay, every project needs to have an audit for fairness and bias. And most of the times it might happen, but sometimes you might say, oh, I think, you know, I'm just going to check these some of these. And so what happens is we cut corners, or we rediscover that something needs to be done. So the idea behind Triage was, let's take commonly occurring problems that we deal with when tackling data science problems in policy and social impact. Let's take the off-the-shelf scikit-learn, PyTorch, you know, TensorFlow type tools that exist to build models, and put a more end-to-end wrapper around it, so that the people using it focus on the questions that are specific to the type of problems. What is your cohort? What is your outcome? How often are you generating these decisions? How much resources do you have to intervene? What evaluation metric? What is your fairness metric? What do you care about? Kind of, that's the configuration overall. And then from there, Triage sort of guides you through each decision. It asks you these types of questions, and tries a lot of different things, and then gives you sort of a structured way of making decisions around what models do I use, what's the impact of my models going stale, how often do I update them, how do I trade off if there is a trade-off between fairness and interpretability and effectiveness and efficiency. So it's really a tool that's our attempt to standardize some of these steps and help people start from this before, instead of starting from scratch and build kind of these end-to-end tools that can go from problem formulation to generating features to validation to building models to interpretation to bias audits and maintenance. So that's kind of the intention. It's open source. We have a few tutorials in there. Tristan's going to go deeper into more. What are the components? How do you use it? But we'd love for people to try it out and give us feedback.
Thanks, Raid. So now up we have Tristan, Tristan was a software engineer at the Center for Data Science and Public Policy, and now he works at Gray Matter Analytics. Tristan, do you want to take it away?
Yeah. Thanks, Ryan. So I worked at the Center for Data Science and Public Policy for a few years as an engineer, and we built Triage over the course of a few years, and development is still going on. I'm going to give a presentation. It's not like really it's not going to be complete just for time reasons, but I'm going to try and go through the basics of how you model a data science problem in Triage. So I'm basing this on some slides that Kit Ridolf, also from Data Science and Public Policy, put together a little while ago. I've made some additions, but yeah, now I'll get started. This slide is mostly duplicative with what Raid was talking about. Though I will add just some more detail about the what one thing that makes our data science for social good projects complicated sometimes if you were to do them from scratch is things that relate to time. So we would often do temporal validation, which we'll talk about more later, but that affects a lot of how you design your data science projects, and it's really easy to screw up. So one of the things we wanted to do is to kind of put that into a library that we could just write once, instead of having data scientists write a million times with slight variations. So that's one example that that made it useful for us to focus on a tool, on an end-to-end tool, is to include some of the more complicated components like that, which are easy to screw up. So yeah, it's an end-to-end tool that includes, as Raid said, initially, I'm designing your what we call an experiment, or a pipeline. It has a few phases. I'm only going to talk about the first one, which is kind of the experimental phase, but we also have tools for model selection and post modeling, as well as for bias and fairness, which we have more resources to look at as well. So just a quick primer to when we say temporal validation. There's as opposed to, so if you're doing data science, you may be familiar with cross validation, where you split data into equal chunks to do training and testing, but often that is randomized. But for temporal validation, we don't really randomize it. We do it by time, with the idea being you're going to have to deploy this at a certain point in time. And when you deploy it, in real life, you're only going to have access to data up to a certain point in time. So it's useful for us to be able to model our the performance like as if you were, say, in this example, in 2007. If you were to have deployed this model that you're building in 2007, how would it have done in 2008, and so forth. Again, yeah, we'll get more into temporal validation later when we go into the time chop section, but that's the basic idea. Triage is a very opinionated tool in that, like, it only works for certain types of problems. And so, like, so what you need to, like, both from a technical perspective and from a project perspective. So it's built, like, right now for like binary classification problems. So what Raid mentioned about like early warning systems and inspection prioritization, those are like examples of problem types which are generally binary classification problems. Like, is like what, you know, buildings or people are at risk of some, like, of something. And so, yeah, it's built around binary classification problems and with temporal data. So that, like, events that happened in the real world is like the primary data source. So, for instance, it's not built for, like, image recognition problems or other things that fall under machine learning, but don't really fit this type of data set. From a technical perspective, it's a Python tool, and it uses Postgres as a database. It will run on any machine that has those. We developed it on Linux, but we've ran it on Windows with some work. It'll run on laptops if the data is small enough to, like, really to really work on your laptop. But we would often deploy it at scale at DSAP in, like, Amazon Web Services. There are some things in, like, post modeling that so I won't talk about, but there are some things that use Jupyter, although the main, like, experiment interface is not Jupyter based. Just a quick, if you want to look at a detailed tutorial, which I don't have time to go through here, but the Dirty Duck tutorial was our, like, the motivating example we're using, named after a certain restaurant in Chicago that has some of the best food in the city, but also gets shut down by the health department a lot. We kind of guided our tutorial around the problem of prioritizing inspections. So that's what we're going to go through here. Where triage comes in your pipeline is after. So it basically assumes that you have data in a database, in a Postgres database, and all of your data has this attributes linked to events with timestamps, because it treats everything as an event. And if your data has that basic structure, you essentially you write a configuration file, which is what the bulk of this presentation is going to be about. You run your models using Triage, and then you use our model selection tool called Audition to go through those results. So this is generally comes after you're, like, if you're working with a project partner, this would come, like, after your ETL step, and after you've done some basic data cleaning and data and exploratory data analysis, so you have a good handle on what your data looks like. And so to kind of make this example more concrete, going to this inspections problem where we're trying to prioritize like restaurant inspections, We have two, we're gonna kind of work with these two tables. Often projects using Triage have a bunch of data sources, but this is kind of like the minimal example to see like the type of information that's useful to Triage. So this, we're gonna call it the entities table. This would basically be a list of your facilities that could be inspected, like list of facilities that serve food in some way. So this could be restaurants, it could be grocery stores. There's some basic information in here. The idea is there's an entity ID, which would be a unique identifier. That is one thing that is pretty, is necessary to really run Triage. Any kind of data source that you're using needs to be relatable to the other data sources that you're using. It doesn't do any deduplication. So if you're working with a database where you don't have that, you can use other tools to deduplicate and get these unique IDs. But for our purposes here, we're going to assume that like the health inspector's office does have these unique identifiers in their database. They have some basic information about them, like what type of facility, and also these date ranges, which are like activity, like whether or not their permits are active. So the implication is that these ones without an end date are currently active, and these ones that have an end date were active at some point in the past. So that's like the basic entity date format. Then the other table is our events table, which is really, it's recording our inspections. So these entity IDs refer back to the entities in the other table. We have a date of inspection, a result of the inspection, and the like risk related to that, like the risk level that the inspector found. In reality, in the default tutorial, we do have more data in here. We have like notes and stuff from the inspectors, but for this example, we're just sticking with these columns. So these are like the two input tables that we're going to use, that we're going to refer to in our triage configuration file. So before I go, so we're kind of at like the stopping, like a break point. I'm about to go into like the overview of the configuration. This is kind of the like bulk of the presentation, but are there any questions that I should answer with like what I presented so far?
I don't see any in the chat. Tristan,
Okay.
I think you've been very clear. I like that you're motivating all the examples. It makes sense.
Okay, thanks. Yeah, I can move on then. So we have like different components that Rai mentioned all these, but I'll go through them in a little bit more detail. The cohort is like the population that we want to model, and we'll talk about this more later. It has like all of these sections I go through in detail, but the cohort is like, yeah, what entities I want to model. The temporal configuration is, how I want to split data, how I want to split the data by time, how often I want to retrain models, what time windows am I concerned with, failed inspections in. The label kind of works with those for saying like what's my outcome? So in our case, it's like a failed inspection, but that, the label is very different for different types of projects. What people spend most of their time in using Triage projects is the feature aggregations and groupings. The system we use for building features makes it easy to create a ton of them. And, if you're getting like, if you have like 5 data sources, 6 data sources, 7 data sources, it takes, you can spend a lot of time just kind of like, I'm designing features. Then we have some tools that do like some parts of the pipeline that do mirror what like you might be used to in libraries like sklearn with a modeling grid where you loop through a bunch of different models and hyperparameters on the same data, as well as like computing evaluation metrics. So these are the main components. We do have more like some more features that are more for power users, but aren't really like, crucial to the understanding of like what a triage experiment is.
I think one thing.
I'm gonna focus on these ones.
Well, I just wanted to add one thing. Is I was talking to Raid, and he was talking through how the configuration tells you everything you need to know about the technical modeling aspect about a project. It's like if you can read the configuration that Triage, it's quite opinionated, but if you can read that, you know everything you need to know about the setup and framing of the problem.
Yeah, it's the way I describe it sometimes is, well, so one thing I noticed at DSAP is so, the structure of DSAP, like the Center for Data Science and Public Policy, is we had like a bunch of products going on at one time. Like maybe we had a team of 12, and we had like teams of like 2 or 3 people. So we would often have, 3 or 4 triage products going on at one time. One thing that I don't know, like perhaps this was in Raid's mind when he was like coming up with the idea, but that I didn't really, see coming until we were in all these meetings, is that it made it pretty easy for a team to present their project to the other teams. So the other team could understand, because these decisions, which are very important decisions, like your cohort and your label, how you're chopping time, are very important. And those are, like once you're using the same framework, it's, it can be easier to express the choices you made, using that framework. And it comes with some cost. For most people, it's probably going to take longer using Triage to like get their first model.
Yeah.
Like if you were like, oh, I just want to like assemble some data really quick and, and run a random forest on it, you could probably do that faster just on your own if you're used to tools like sklearn. But as the project becomes more of like a production ready project, the features you have to add to that pipeline get, there's more and more friction to adding those. So this kind of like
it doesn't scale.
I'm sorry, I didn't hear that.
Sorry, it just doesn't scale.
Yeah. So this is kind of like in Triage, kind of like it forces you to think about more of these up front, with the goal that like with the idea that like if you've done more of this up front, then you won't be scrambling to implement them, a couple months into the project. So yeah, I'll trying to be conscious of time. So actually, so are we at a hard stop in 9 minutes? Because I might have to speed this up more.
Andrew, do you know if we're at a hard stop?
I think so. Yeah, like as close as we can to being done on time.
Yeah. Okay. So I will go through. So we're going to post these slides. I'll go through these a little bit. I think what I'm going to skip is the like explanation of like the details of what's in the config. I think I'll just try to motivate these, well, like to kind of like talk about how we're doing these, like how we represent these in our data a little bit, and hopefully that's gonna like allow people to do more reading on our documentation later if they want. So designing a cohort, yeah, these are the entities we include in modeling. So in this case, we're talking what facilities we should consider for inspection. Active facilities are what we want. We don't want to send inspectors to places that don't have permits anymore. And it sounds like a basic thing, but it's also, it's a real problem to deal with in data if you're prioritizing inspections. So that start date and end date I talked about before is key to that. That like that's where we have that in our data. So yeah, we specify that with an SQL query. You'll see an as of date in brackets. And this is actually, I'm going to explain this on this next slide. This is probably like, if I explain anything, this is probably one of the most important things. So I'm going to spend a little bit of time on this. We call this an as of date in Triage, or we actually threw around a few names, but it's basically, it's like you're doing time travel. Like what if instead of today being July 30th, it was January 1st, 2011, how would I model if this was that date? And so, yeah, we explained temporal validation a little bit before, but as of date is how Triage uses this in modeling. So all of these database things like the features, the labels, and the cohort use what's called an as of date to, when Triage crunches your time config, it produces a bunch of dates that it wants to compute, that it wants to model data on. So if you're inspecting once every few months, you're going to have one of these as of dates once every few months, and that you want to generate features, you want to generate outcomes based on that date. So the idea is that instead of having to reproduce this data for every date, you give it a template. You give it a template that has this as of date, and then your query is saying like at some particular point in time, this is my, like, is the facility active? So yeah, I know I spent quite a bit of time on that. I'm not going to try and make you into an expert on temporal validation right now. I did link to a deep dive, but essentially this is how to instruct Triage how to do the time math that's important for your problem. So it loops through a bunch of stuff. You can tell it like when to start making features, when to start making labels, how often to update, what your label time spans are, which I will explain. How do you define your outcome? So for this inspections problem, we're talking what facilities will fail inspection within a time frame. So like if you're scheduling for 6 months or 2 months, you're and by scheduling I mean scheduling inspectors, you're trying to generate an inspector, like an inspector schedule for these for the 6 months. So you want to know which facilities are going to fail inspection within the next 6 months. So the label design is kind of, it starts off pretty similar to cohort design, but it includes the concept of this label time span because you might want to iterate over different label time spans. So like with this one label config, you can test, okay, I want to see, you know, inspections over 1 month or 2 months, whether or not you're going to have any failures. Feature aggregations. I probably don't have time to do this justice. What I do want to say about collate, which is what we use in Triage for generating for generating features, is that it's focused on generating large numbers of event aggregations. So it's easy to do things like I want to generate SQL queries that get the count of inspections over the last month, over the last 3 months, over the last 6 months. You can give it a bunch of different quantities that you're trying to count, a bunch of different aggregation functions, a bunch of different time intervals. It'll combine all of those together. So like you can, with like a little bit of config, you can end up with, you know, a few dozen features like really quickly. The same, we kind of look at categoricals, which are what we call like, okay, all the ones that are high risk, all the ones that are low risk, all the ones which are medium risk. There's like a section for that as well. Model algorithm. So this is more basic, what people might be used to in like sklearn. That's just like iterating through a bunch of different model algorithms and hyperparameters. It will do that for you. And then I think the last thing that's kind of like is unique, not unique, but is like important to Triage that isn't necessarily important to a lot of data scientists is you're not often just looking for accuracy, you're looking for accuracy or like precision or recall on specifically like the facilities that you have the capacity to look at. So if I have the capacity to do 250 inspections on every quarter, do I care about accuracy for the whole list? I might not. I might care about how well these models are performing on those 250 highest facilities. Like if I send inspectors to these 250, how many of them are going to be hits? How many of them are going to be misses? How many of the real hits are not going to be inspected? So we use that in our evaluation config, where you can specify these thresholds. You're saying like, I want the top performance on the top person, top 5 people, top 10 people for facilities. So once you've done all that, you run triage either as a Python package or command line. You get results in a database, like in your Postgres database, where you can look at your results. You have some other features, like you can put your, like what your partner's doing currently. Say if they're randomizing their inspection, scheduling, you could put that as a model into your modeling grid. So you can use all of our tools for model selection against those. You can see the lift over what the partner's doing. You can create some feature groups to answer the question, how crucial is like this data set to my model's performance? And as mentioned before, the triage results go right into the like next step tools of like audition and post modeling for taking the next step. So you can look at our tutorial, the Dirty Duck tutorial. There's a quick start guide, and we have some case studies of like real projects that were done and their triage config. You can also go to the repository, github.com/gssg/triage, if you want to see what's going on with the repo currently. That's all I have. 11:29.
Thank you so much, Tristan. Yeah, really bringing us in under the wire. Yeah, if anybody wants to go ahead and look at triage, it can. I think the framing that we did around this was that it can help you build America's next top model. And if you go and you look at the components, they're called things like audition and collate. And I think at one point post modeling was called Tyra.
Yep.
So that's there. But thank you so much, Tristan, for attending today and presenting, giving us this tutorial. Thank you, Ben Brew. Thank you to the participants from CPAL and also from AmFan. Next week, as Jane mentioned, we'll be talking about bias and fairness, and we'll have some really special guests in 2 weeks' time. And then that's all for me. Andrew, do you want to close us out?
Yeah, so thanks everyone for coming. Thanks to all the panelists. It looks like we still have a couple on, so thank you guys, Tristan, Ben, Ansel, and Tanguy. And so like Harim said, next week is going to be on bias and fairness, and we would really appreciate it if everybody kind of spreads the word about these webinars, sharing over Twitter, retweeting the Data Science Fellows Twitter, and everything. We put a lot of effort into running these, and we want as many attendees as possible. So thanks everybody, and I guess we'll speak more in the Solve for Good Slack workspace.
Bye everyone.
Bye everyone.